This is Mr. Fagan. I'm the math teacher on Team 1, and today I'm going to show you a short video on geometry. The question that we're dealing with says we have a triangle ABC with the vertices -4, 0, -1, 6, and 3, -1, and we're interested in finding the perimeter of the triangle, rounded to the nearest tenth. So in order to visualize what we're looking at here, let's take a look at this on the graph. We know that perimeter is distance around the outside. So if I pull up a graph here, let's graph this guy. Go here. We'll put our points in blue. So -4, 0, -1, 6 is here. 3, -1 is down here. So let's connect the dots here. We have a triangle. Again, we're interested in the distance around the outside. That's the perimeter. And in order to do that, I need to find the distance between the points 3 times. So you can use either the distance formula or you can use Pythagorean theorem. I'm going to do it using Pythagorean theorem. So I'm going to create right triangles. So if I create a right triangle, I can count lengths vertically 1, 2, 3, 4, 5, 6, and 1, 2, 3. And if I call that side A, then I can calculate the distance or the length of side A by using Pythagorean theorem. So I know that A squared equals 3 squared plus 6 squared. So that's 9 plus 36. A squared is 45. That means A is the square root of 45. So I have one of the side lengths. If I do that again twice, then I'll have all 3. And then I can add them up and get the perimeter. So let's do it again down here. Let's create this right triangle. That's side length 1. 1, 2, 3, 4, 5, 6, 7. That's 7. So if I called that side B, I would say that B squared is 1 squared plus 7 squared, which is 1 plus 49. That's 50. So B is going to be the square root of 50. And then one last time, let's create a right triangle here by going horizontal and vertical. I have 1, 2, 3, 4 on a side. 1, 2, 3, 4, 5, 6, 7 on this side. We'll call that side C. So C squared is 4 squared plus 7 squared. That's 16 plus 49. That's 65. So C is the square root of 65. So I have my 3 lengths, square root of 45, square root of 50, and square root of 65. And rather than getting the decimal equivalent to all of those and adding them up to avoid rounding error, let's just go to our calculator. So we have the square root of 45 plus the square root of 65. And the last one was square root of 50. So the nice thing about the Desmos calculator is that it actually calculates it as I go, so I don't even have to hit enter. It tells me that they add up to 21.84, and since I'm rounding to the nearest tenth, I go to the second decimal place 4, and that tells me to leave it 21.8. So let's type that in, see how we did. 21.8. Go over here and let's score it. It says that correct. Student identifies a correct perimeter, providing evidence of the ability to use coordinates to compute perimeters of triangles. So I hope that made sense. Thanks for listening and good luck.